Okay, guys, let's begin the class. So, yes, good evening, everyone. Nice to see you have plus 80 people today. So, let us begin. Yeah. So, yesterday, the final topic we did was comparison between rigid pavement and flexible pavement. So, it is safe to say that flexible pavement is kind of over, and today we will be beginning with rigid pavements. So, without any further ado, directly more rigid pavement ma ke huncha. So, rigid pavement को most important property के थियो. So flexible मा it was grain to grain transfer for the distribution of load, and rigid pavement मा can you guys guess most important property के थियो load को regarding कसरी load bear गर्थ्यो. Yes, awesome. It is on account of slab action or flexural strength. Flexure को अर्को synonym के थियो. Another word flexure. Yes, awesome. Bending. So bending strength हुन्छ basically, right? अन्त यसमा subgrade त्यति साह्रो बलियो पनि चाहिँदैन, unlike pavement, flexible pavement where we need very strong subgrades. So it's something like that. So basically what we do is we construct an RCC slab in case of different layers of flexible pavement. यसमा basically 3 layers हुन्छ in relation to flexible pavement which has 4 layers. So यसमा 3 layers के हुन्छ, bottom को sub base कुनै लगाउँछ, त्यहाँदेखि slab action, and at the top surface को लगाउँछ. That's it. So considering these properties of rigid pavements, let us introduce some terminologies. For rigid pavements, the first terminology for rigid pavement is modulus of subgrade reaction. Okay, it is represented by K, and its formula is small p divided by 0.125, where P is the pressure in kilogram per square centimeters. Okay, this is the first one, which is called the modulus of subgrade reaction. Can you remember this formula? Okay, guys, can you remember this formula? Modulus of subgrade reaction, K is equal to P by 0.125. Okay, where P is the pressure in kilogram per square centimeter. Second parameter, it is called relative stiffness of slab. So slab bane, it is a rigid thing, right? It is a rigid thing, so it is stiff. Stiff ko matlab hat pat bend bhayhaldena, right? Flexural strength छ, त्यसले गर्दा it resists bending, so it is some sort of stiff. त्यो stiffness देखाउनको लागि it is this parameter which is represented by small l. So small l is equal to EH cube by 12 1 minus mu square into k to the power 1 by 4, where E is the elasticity modulus, small h is slab thickness, k is modulus of subgrade reaction. So यो थियो exactly त्यही हो. Now can you guys tell me mu के हो? I think you must have studied it in SOM. हाम्रो अश्विन सरले पढाएको थियो, right? Mu चाहिँ के हो basically? Can anyone comment in the chat? Yes, awesome guys. Mu is the Poisson's ratio. Okay, Poisson's ratio. So तपाईँलाई relative stiffness of slab, radius of relative stiffness of slab खोज्नु भन्यो भने it will be represented by L. यसको युनिट चाहिँ मिटर्समा हुन्छ. ओके, यति एउटा पर्टिकुलर लेन्थ चाहिँ स्टिफ छ भनेर देखाउन खोजेको क्लास अरु के हैन. Where E is the elasticity modulus, तपाईको H is the slab thickness, K is the modulus of subgrade reaction, mu is the Poisson's ratio. Okay, this is the second terminology. Let's move to the third one. Third ma equivalent radius of resisting section. So यहाँ माथि relative stiffness of slab मा हाम्रो length हामीले कन्सिडर गर्दै थियो. सपोज एउटा कुनै स्ल्याब छ र त्यसमा चाहिँ यति पोर्सन चाहिँ यति पर्टिकुलर लेन्थ चाहिँ निकै स्टिफ छ, अन्त त्यसले पुरा रेजिस्टेन्स प्रोभाइड गर्छ. इक्विभ्यालेन्ट रेडियसमा चाहिँ व्हाट विल ह्यापन इज एउटा स्मल पर्टिकुलर एरिया, एउटा स्मल पर्टिकुलर रेडियस. सपोज यसको मैले प्लान भरे, इफ आई लुक एट इट इन अ प्लान पर्सपेक्टिभ, यो एरियाले चाहिँ रेजिस्ट गर्छ. त्यसमा चाहिँ सपोज दिस इज द रेडियस स्मल ए, right? So this is the radius, small a, it is represented by small p. So that is the radius of resisting section, and the formula of this is given by 1.6 a square plus b square, sorry, it's not b, it's h square, minus 0.675 h when a is less than 1.724 h. So a is greater than 1.724 h or equal to 1.724 724H garemche, then the value of B will be equal to small a. So यसमा चाहिँ small a is the radius of wheel load, small h is the h generally thickness of slab. So this is called the radius of resisting section. So guys, kept your formula here basis I'll give you some MCQs. Okay, today we are going back to the normal modus operandi. We'll be following that. So guys, please look at this formula. Modulus of subgrade reaction K is equal to P divided by 0.125. Relative stiffness L is equal to EH cube by 12 into 1 minus mu square into K to the power 1 by 4, where K is the modulus of subgrade reaction, mu is the Poisson's ratio, H is the thickness of slab, E is the elasticity modulus, and equivalent radius of resisting section root over of 1.6 a square plus h square minus 0.675 h when a is less than 1.724, greater than 7. It's very easy for us to calculate. Is it okay, guys? Can we move towards the MCQs? If so, please give me a thumbs up. Okay, guys. Awesome, guys. Let's go to the MCQs. Okay, so this is the first MCQ. I think the polls are on. Okay, the polls are on. So let us calculate the radius of resisting section. So I'm given K. Let's see. Calculate the radius of resisting section. Radius of resisting section is given by B. Okay, of a 20 centimeter slab. H is equal to 20 centimeters. Given the radius of contact area, that is small a, is equal to 15 centimeter. So we know basically B ko value ko thiyo, there are two choices. Root over of 1.6 a square plus h square minus 0.675 h when a is less than 1.724 h, greater than equal to 1.724 h when I'm say small a. Okay, so guys, please calculate whether a is less than 1.724 h. So calculate, take the value of h, see whether you satisfy garcha ki garदैन. Okay, यो म गरिदिहाल्छु, no issues. A हाम्रो 15 छ, 1.724 into h is 20, so that will give you 1.724 to 20 गर्दाखेरि 34.48. So 34.48. So A is 15. 15 is less than 34.48. त्यसले गर्दाखेरि first को जुन चाहिँ formula छ, this will be applicable. Therefore, B will be equal to root over of 1.6 a square plus h square minus 0.675 h. So using this formula, using these details, please give me the value of B. Garera, kindly participate in the poll. Come on, guys. I'm waiting for you guys. 5 votes are in. Let me see. Guys, I'll write karegi wrong. Please solve. I'll be waiting for you guys. We have 12 votes in. Come on, guys. 20 votes in. I'm the 1/4 vote garisaknu bhako cha. Remaining guys, come on. Use your calculators. Speed up the calculation process and submit your poll. Let's wait for 15 more seconds, then I'll solve the question. Okay, then we can close the poll. So B is equal to 1.6 into a square plus h square minus 0.675 into h. You गर्दाखेरि okay, अलिक लामो पाराले नै गरिदिन्छु तपाईहरुको लागि. 6 into 15 square gives you 360 plus 400 minus 13.5. That is root over of 760, 27.568, 13.5, 14.06807, which is option number C, which most of you guys have given me the correct answer. Is this clear? Your first question, is it clear? If so, please give me a thumbs up, right? Okay. I hope ajuko chai it's quite simple. Aile saman simple नै लाग्यो right? Hijo त्यति confusing थिएन. Okay, fine. Awesome guys. So let's see if I have another of the same question for you guys. I have to choose the like. Okay guys, can you solve this? Please participate in poll number 2. Okay, I'll just write the formula for you guys. Equivalent radius of resisting section. Please participate in poll number 2. I'm just writing the formula for you guys. Okay, what is given? The resisting section of slab thickness is 20 centimeters. Ratio of wheel load distribution to the thickness of the slab. So radius of wheel load is A, thickness of the slab A by H is 2. So you दुईटा चीज हामीले दिएको छ त्यो दिएर please calculate, please find the value. Please participate in poll number 2. Come on guys, please participate. First is तपाईले हेर्नुपर्छ whether A is less than 1.724h or A is greater than equal to 1.724h. त्यो दिएर कुन चाहिँ फर्मुला एप्लाई गर्ने and accordingly you will get the answer. That's a beautiful question. तपाईले त्यही प्रोसेस फलो गरे पनि you'll get the answer. I'll wait for 30 more seconds. So तपाईहरुले vote गर्न सक्नु छिटो vote गरिहाल्नुस्. Okay, then we can end the poll. So please concentrate guys. First is whether A is less than 1.724h. So let us consider this. Here we get you cross multiply A is equal to 2h. So A is equal to 2h. So is 2h greater than 1.724h? Is it guys? If so, please give me a thumbs up. Yes, awesome. Yo greater than somebody will be using this particular thing. So hamro B is equal to A. So A ke थियो hamro, it is 2h according to the question. 2 into h. H को value दिएको छ हामीलाई. It is 20. That is 40 centimeters, which is option number C. ठीक छ. Question मजा आएको थियो. What do you guys think about the question? It was a good question, right? Awesome guys. So दुईटा टाइपको हामीले गर्यो. यो टाइपको गर्यो, यो टाइपको पनि गर्यो. So I don't think you'll have any issues with radius calculation of radius of resisting section. Let's move to the next terminology. Yo हाम्रो B सक्यो. Let's go to calculation of L. Okay, the next question. So अब चाहिँ radius of relative stiffness. So let me go to the theory. Radius of resisting section we just did. 3 is done. Now radius of relative stiffness, we'll do this particular thing. Radius of relative stiffness. This is given by this formula. L is equal to EH cube 12k 1 minus mu square 1 by 4 1 to the power 0.25 गर्दा was ways of calculation. Okay, so in this case guys तपाईलाई याद छ भने you can please participate in poll number 3. ल poll number 3 you can participate in poll number 3. I'll just give water provided for us in the question. Radius of relative stiffness of 15 centimeter thick cement concrete slab. Okay, and the modulus of elasticity is given as 2.1 into 10 to the power 5 for ease of calculation, and the Poisson's ratio is 0.13, and there are two modulus of subgrade reaction. K is 3 and K is 7.5. So you duita case ko lagi we need to find the radius of relative stiffness. Okay, L1 and L2 ko numbers. So I'll help you guys with the calculation of L1. Then you guys can calculate L2. So L1 is equal to, I think you guys are voting also. Let me check that also. Poll number 3. Okay. L1 is E 2.1 into 10 to the power 5. H is 15 cube divided by 12 into what is K? K is 3 for the first case, and 1 minus 0.13 square to the power 0.25. So let me calculate power 5 into divided by 12 into 3 into 1 minus 0.25. That gives you 66.89 centimeters. Okay. So please calculate L2 and participate in the poll. Okay guys, I'll be waiting for you guys for the value of L2 where K is equal to 7.5. And kindly participate in the poll. Okay guys, we already have 5 votes in. 10 votes. We have 10 votes. Come on guys. Let's wait for 30 votes. Then we'll close the poll. 25. Okay, I think we can safely end the poll now. So I'll just give you the explanation for this. 2.1 into 10 to the power 5. 15 cube. It's the same thing. 12 into value difference. 7.5 into 13 square to the power 0.25 gives you 53.2 centimeters, which is option number A. Is this okay? Can we move forward now? Guys, I think we can move forward, right? Okay, awesome guys. This is pretty simple in comparison to what we did yesterday. Okay, I think these are very interesting concepts. Okay, fine. Now let's go to a little bit more theory. So Amro, okay, I think we scum theory slide. Once, please give me a second. Okay, it's kind of like the same thing. Let me delete this. It's kind of like the same thing. Okay, fine. It's not that. Okay, so let's move to the next thing. So the next terminology here is Westergaard stress equation. Okay, so consider this to be a rigid pavement, or keyword. Consider this to be a rigid pavement. Okay, so your rigid pavement ma, this is the interior region, this is the corner region, and this region and this region are the edges. So, according to the Westergaard equation, interior region ma stress कति लाग्छ, corner region ma stress कति लाग्छ, and edges ma stress कति लाग्छ. यसको लागि we have formula. So basically, it is for stress calculation. So, interior region ma I, sigma I, stress can be calculated by 0.316p divided by h square into 4 log L by B plus 1.069. मैले यहाँ log को मुनि के नलेखेको मतलब चाहिँ base 10 हो. Please remember that, right? Then we have at the edge 0.572p by h square. It's quite similar, हेर्नुस्, 4 log L by B plus 0.359. And finally we have sigma corner, that is 3p by h square 1 minus a root 2 by L to the power 0.6. So these three are the important stress calculating equations as per Westergaard. Okay guys, is this clear? Okay, we need to remember this formula. This is a necessary evil. There is no two ways about it. Okay, solve garday gayo pani yaad bhayihalcha, त्यस्तो के problem छैन. Once, twice, the revision software ma 3-4 times garदाखेरि yaad bhayihalcha. Okay, so these are the formula. So I think we have a question regarding this Westergaard theory ke basis ma. Let's see. Yeah, we have this question. So this is the particular question. Rather than an MCQ, we can directly find the answer for this particular question. Let's see. So the question states, calculate the stress at the interior edge, sigma I, and the corner region, sigma C, of cement concrete pavement using Westergaard stream equation. Okay, just let me space it apart. Sigma C, corner ra isko lagi. So interior equation we have is 0.316p by h square into 4 log L by B plus 1.069. And isma pani tapaiko cha 3p by h square 1 minus a root 2 divided by L to the power 0.6. Now, what we have been given, P is equal to 4100 kgs, modulus of elasticity 3.3 into 10 to the power 5 kg per square centimeters, Poisson ratio 0.15, modulus of circuit reaction is 25 kg per cubic centimeter, radius is 12 centimeter, pavement thickness is 18 centimeters. Okay, so you equation ma, can you tell me what L is? L1 is Q. Can you comment in the comment chat box? L1 यहाँ त कुनै L छैन, right? L1 के हो? Come on guys, भर्खर पढेको थियौ हामीले, radius of relative stiffness. Okay, and what about B? Radius of R बाट radius of, come on guys, if you can remember, resisting section. Okay, awesome. Then so यसको formula के थियो? So we need to calculate L and B, किनकि यसमा त L र B use हुँदैछ नि, right? And यसमा AL, यसमा मेल हुन्छ, H त हाम्रोमा छैन. So let me push this a little down. Can you guys please calculate the value of L? L कति हुन्छ? Please तपाईले निकाल्नु भएर, can you comment in the chat box? 25. I'll be waiting. Come on guys. Please calculate the value of L and please calculate the value of B. Okay, मैं लिख दिया आंसर कैसे है ना, 3 into 10 to the power 5 into 18 cube 12 k. Come on guys, please tell me the value of K. L 22.29 your answer acts. Come on guys, or will comment गर्नुस्, then I'll check. तपाईको एकजना पेयरले आन्सर दिइहाल्नु भयो. Come on guys, 50.61. So दुईजना बाट let's see के छ, एकखेप दुईजना एकखेप क्रस चेक गरि हेर्नुस् whether you're correct or not. 50.61. So एकखेप I think 15.61 is the answer. Let me check. 0.563 into 10 to the power 6 to the power 0.25. Yes, it is 50.61. Okay guys, 50.61 centimeters. And radius of resisting section चाहिँ के हुन्छ भन्दा A र H गर्नु पर्यो. So 1.724 H is equal to 1831.03, which is greater than A. So use this formula. So B is equal to B को value कति आउँछ? Can you please tell me now? Calculate गरेर निकाल्नुस् B को value. Come on guys, निकाल्नु भयो, please let me know the answer. Yes, awesome. 11.4. Okay, guys, 11.4. Yes. Correct, guys. Correct. यो दुईवटा भ्याल्यु हामीले पाइहाल्यो. सरी, यो भ्याल्यु र यो भ्याल्यु हामीले पाइहाल्यो. सो म यहाँ माथि लेखिदिन्छु ल. Basically what we have is, okay, L is equal to 50.61 and B is equal to 11.4. Okay, so यो दुईटा तपाईले पाउनु भएर यो दुईटा भ्याल्युज तपाईले पाउनु भएर प्लिज क्याल्कुलेट द भ्याल्यु अफ सिग्मा 1, that is interior stress and corner loading stress. Okay, by the way guys, anyone is stuck in any portion, you can raise your hand la. कोहीले कहीँनिर अड्केको छ भने चाहिँ, if not, please solve these two values. Solve for these two values. इन्जिनियरिङमा हाम्रो क्याल्कुलेसन हेज टु बी भेरी स्विफ्ट. यही पाराले गऱ्यो भने चाहिँ हाम्रो विल बी एक्जाम रेडी. Okay, so guys, please follow the same way that you have been solving till now. You will get in the exam mode. Okay, you can type both answers together. That'll be easier for you and even easier for me also. Anyone has commented? Just let me check. I think then you're right. K Wongchuk is also right. Sahil Sharma is also right. So no Vayavani, please calculate for sigma C for the corner. Okay, I'll solve this thing. 50.61 divided by 11.39 or 4 plus 1.069. Okay, this will give you, I'll directly write the answer, 14.63, sorry, 14.63 kilogram per square centimeter. This is centimeter, my guys. Okay, Top then has commented, please guys solve the second one. So it's the same thing. 3 into 4100 by h square was the formula. 1 minus a root 2 12 root 2 by 50.61 to the power 0.6. Garda, yes, you guys are right. It is 18.25 kilogram per square centimeter. Okay. So these are the two values that you will get at the end. Guys, is this clear? If it is not, please give me a thumbs down. If it is clear, please give me a thumbs up. Come on, I need more guys. I hope today is not as miserable as it was yesterday. Okay then, can we move to the next question? Okay, let's move to the next one, I feel. Right? Okay. So, okay, now we come to very interesting portions of the syllabus. Okay. Now we move to very interesting portion of the syllabus. So, guys, what are joints? Can you please tell me? Joints भन्ने के हो? हाम्रो knee joint हाम्रो human body को joint भनेको हैन, in terms of road. What are joints? What are joints भन्दाखेरि पनि, can you tell me some example of joints? कहाँ सुनेको होला तपाईले? Yes, one is, okay, I'll just write it down है तपाईले भन्नु. One is expansion joint. Any other joint? Come on guys. Yes, contraction joint. Slip joint. So हाम्रो rigid pavement को लागि it is not very yes. So then construction joint. One more, drainage joint. No, there's nothing called drainage joint. Here L बनाउँछ तपाईले मिस गर्नुहुन्छ. यसको तपाईको anti हो तपाईको. Yes. Pranay, you're absolutely right. Come on, full form लेख्नुस् त कहिले. Can you please write the full form? L बनाउँछ. Yes. Pariskrit, you're right. For Mit, Pranay, we have longitudinal joint. Okay, we have longitudinal joint. So I'll just draw a small diagram. Okay, you have a rigid pavement, for example. Use basically direction of movement. Okay, so you got the direction of movement and use the transverse direction method. Okay, so you particular topic what we do is basically. So we break the pavement, the rigid pavement, in a straight line. We break the rigid pavement in a straight line. Break width very small, 6 to 8 millimeters, very negligible. Okay, 6 to 8 millimeters. So bhatkanu along the width is called basically longitudinal joint. Okay, breaking or having a small gap in a rigid pavement along the longitudinal direction is called longitudinal joint, and this is joined by rod basically, and these rods are called tie bars. Okay. Similarly, in the transverse direction, यो particular direction ma along the width अब यो चाहिँ along the length थियो नि हाम्रो longitudinal joint, right? Along the width हामीले भत्काइदिन्छ. तपाईले देख्नु भएको होला. Have you seen this? By the way, have you observed this in rigid pavements? If so, please give me a thumbs up. देख्नु भएको होला, right? Have you seen this type of spacing between pavements, right? So along the width तपाईको these are called contraction joint. Okay, and यसलाई पनि certain bars ले मुनिपट्टि जोडिरहेको हुन्छ ग्यापको लागि ताकि भत्केर टोटली भत्केर चाहिँ नजाओस् भनेर. And these bars are called dowel bars. Okay, now one important difference you need to note here is यो जुन चाहिँ tie bar छ, it is only to hold two parts of pavement. So यो एउटा पार्ट भयो, सेकेन्ड पार्ट भयो, त्यसलाई चाहिँ जोडेर राख्नको लागि मात्रै हो. While dowel bar in case of contraction joint, it holds two parts, त्यो त छै छ, but it also transfers load from one panel to the other. This is the major difference. Contraction joints ma we have something called dowel bars. हुनु त त्यही हो, रड नै हो. यसमा dowel किन बनेको भन्दा यसले load transfer मा पनि participate गर्छ. Okay, is it clear? Contraction joint, longitudinal joint. If so, please give me a thumbs up. Come on guys, this is a very important concept. Okay, तपाईलाई अलिक ध्यान दिनुस्. हाम्रो what I've observed is हाम्रो तपाईको JEE 2013 देखि लिएर हाम्रो AE exam 2018, even combined recruitment is 22, and even the undersecretary exam 2017, I think यो joint को बारेमा एउटा question आएको थियो each exam मा, I think, as far as I know. So it is very important that you understand this concept. Okay, longitudinal joint, I hope you understood. Contraction joint in the transverse direction, यसमा चाहिँ dowel bar हुन्छ, यसमा चाहिँ we have tie bars. Now an important thing, load transfer. Okay, so longitudinal joint ma, I'll just write over here, maximum spacing is given as 140 meter as per the IRC code ले भन्छ. Longitudinal joint suppose हुँदै थियो रे, अन्त कति टाइमको लागि longitudinal joint लाएन अरे, त्यो दुईटा सक्सेसिभ longitudinal joints को बीचको स्पेसिङ चाहिँ 140 मिटर भन्दा ज्यादा एक्सिड गर्नु हुँदैन. त्यसको भित्र नै अर्को एउटा longitudinal joint आइहाल्नु पर्यो, so that it prevent warping of concrete. Warping basically भन्यो भने भत्केर नजाओस् भनेको. कतिहरु expansion, कतिहरु contraction हुन्छ, त्यसले गर्दा चाहिँ भत्केर नजाओस् भन्दैछ. So that is the reason why we put maximum spacing as 140 mm. And joint जुन चाहिँ हाम्रो यो छ, यो particular joint छ longitudinal, यसको thickness, joint thickness तपाईको हुन्छ 2.5 centimeters. Okay, this is for longitudinal joint. Now if we consider the contraction joint, यो चाहिँ हाम्रो transverse direction मै छ. So contraction joint हामीले किन लगाउँछ? It is done to relieve tensile strength of concrete due to temperature changes. हाम्रो हिट हुँदाखेरि बेसिकली एक्सप्यान्ड हुन्छ, विन्टर आउँदाखेरि कन्ट्र्याक्ट हुन थाल्छ. त्यसले गर्दाखेरि डिफरेन्सेस इन तपाईको द चेन्जेस इन द एक्सपेन्सन अर कन्ट्र्याक्सन ले गर्दाखेरि देयर इज possibility that the concrete will crack because जग्गा कम्ती भएर त्यहाँनिर, right? So we provide contraction joint along this particular direction, that is in the transverse direction. Now यसमा तपाईको important एउटा detail चाहिँ you'll have to remember. For reinforced joints having a thickness of 10 centimeter, 15 centimeter and 20 centimeter, the spacing can be given as 7.5 meter, 13 meter and 14 meter. So basically spacing भनेको दुईटा हाम्रो joint छ contraction joint को बीचमा spacing चाहिँ, suppose pavement को thickness 20 centimeter थियो भने it has to be 14 meters spacing, 15 centimeter छ भने 13 meter spacing and thickness चाहिँ 10 centimeter छ भने 7.5 centimeter spacing, 7.5 meter spacing. This is given by the Indian Road Congress. Okay, so these are some values that you need to remember. Contraction joint तपाईले बुझिहाल्नु भयो. Transverse direction मा double bar हुन्छ, उसले load transfer गर्छ. And तपाईको IRC ले के स्पेसिफिकेसन दिन्छ भन्दाखेरि it is due to स्पेसिफिकेसन दिन्छ भन्दाखेरि spacing for 10 centimeter is 7.5 meters, 15 centimeter को लागि 13 meters and 20 centimeter को लागि 14 meters. These are very important values. Okay, that's why I'm repeating it again and again. And contraction joint किन हामीले दिन्छ? To relieve the tensile stress of concrete due to temperature changes. और यसलाई पनि warping नै भन्छ. Warping वार्पिङ बेसिकली को मतलब नै के हो टेम्परेचर चेन्जेसले गर्दा भनेको एन्ड लङ्गिट्युडनल जोइन्ट अलङ लङ्गिट्युडनल डाइरेक्सन अगेन वार्पिङले गर्दा नै हो जोइन्टको थिकनेस 2.5 सेन्टिमिटर्स एन्ड म्याक्सिमम स्पेसिङ बिट्विन टु लङ्गिट्युडनल जोइन्ट्स इज 140 meters. Is it okay, guys? The information I think you can grasp, right? I hope you can grasp this much of information, right? Okay, guys, these are important, very high ROI, return on investment details that you need to remember. Okay, contraction longitude. Now, okay, awesome, guys, awesome. Thank you for the response. Awesome, guys. Now, let us move to expansion joint के हो, construction joint के हो. Okay, यो दुईटा त तपाईले kind of like your inverse type को छ, direction perpendicular to each other, so बुझिहाल्नु भयो. But expansion joint अब के हो? तपाईकोमा थट आयो लङ्गिट्युडनल र एक्सपेन्सन त एउटै हैन भनेर कोही बेला हुनु पनि सक्छ बट एक्चुअली हैन. सो एक्सपेन्सन जोइन्ट के हो? इट इज इन द ट्रान्सभर्स डाइरेक्सन. हाम्रो कन्ट्राक्सन जोइन्ट जस्तै नै हो एक्सपेन्सन जोइन्ट पनि. ओके, तर दिस विल एक्ट अलोङ द फुल डेप्थ जुन चाहिँ भत्काएर जाँदैछ नि, यो यही डाइरेक्सनमै हो तर फुल डेप्थमा जान्छ यसको फर द एक्सपेन्सन जोइन्ट. अन्त यसको तपाईको बेसिकली यहाँ चाहिँ टेन्साइल स्ट्रेस रिलिज गर्दैछ, यहाँ चाहिँ compressive stress लाई रिलिभ गर्छ. ओके, नीड टु बी भेरी केयरफुल. टेन्साइल स्ट्रेस रिलिभ गर्ने कन्ट्राक्सन जोइन्ट हुन्छ, एक्सपेन्सन चाहिँ कम्प्रेसिभ स्ट्रेस, तर बोथ एक्ट इन द सेम डाइरेक्सन, द्याट इज अ ट्रान्सभर्स डाइरेक्सन. यसको विड्थ हुन्छ तपाईको भत्काउने विड्थ हुन्छ 20 to 25 मिलिमिटर हो. यसमा पनि डबल बार नै हुन्छ लाइक द्याट अफ तपाईको कन्ट्राक्सन जोइन्ट. एन्ड एज पर द IRC द लेन्थ बिट्विन द टु एक्सपेन्सन जोइन्ट इज 45 meters. Okay, length between the two is 45 meters. Okay, this is for expansion joint. And finally, construction joint. Suppose there are pavement construction thalde the tara because suppose due to lack of land compensation abruptly हामीले pavement रोक्दिनु पर्यो अरे, right? एउटा एन्डमा रोक्दिनु पर्यो अरे. So at the end of the structure or the end of the pavement, एउटा joint हामीले create गर्छ. That joint is called construction joint. Okay, when the construction was stopped due to some sort of reason, suppose land compensation पाएन, अन्त land बनाउन दिएन, or the breakdown of कुनै machinery थियो अरे, right? घरिघरि procure गर्नु difficult छ, त्यसले गर्दाखेरि चाहिँ यो चाहिँ it is not allowed भन्यो भने then the joint prepared at the end of the pavement, that is called construction joint. Okay, so now please concentrate. There is another piece of trivia here. Pre-stressed concrete. Pre-stressed concrete ko lagi, the length between the joints is 120 meters. The width is 3.6 meters and the minimum thickness for a pre-stressed concrete is 15 centimeters. Use khali small piece of trivia lagi, okay? The length between the pre-stressed concrete is 120 meters, basically spacing bhaneko मैले. The width 3.6 meters minimum and the minimum thickness is 15 centimeters. Okay guys, so this is very content rich information. I hope you were able to grasp this. Okay guys, do you want me to repeat this? Repeat garnu? Okay. I'll just repeat this once, then we can go to the MCQs. Okay, I'll start with the expansion joint. So, expansion joint पनि transverse direction मा हामीले सानो भत्काउँछ हामीले. किन भत्कायो भन्दा यो कम्प्रेसिभ स्ट्रेसेसलाई चाहिँ रिलिभ गर्नको लागि. कतिवटा केसेसमा टेन्साइल एक्ट गर्छ, राइट? टेन्साइल कहिले एक्ट गर्छ भन्दा एक्सपान्ड हुँदाखेरि टेन्साइल, हैन, कन्ट्र्याक्ट हुँदाखेरि टेन्साइल हुन्छ, एक्सपान्ड हुँदाखेरि द कम्प्रेसिभ स्ट्रेस हुन्छ नि, किनकि एक्सपान्ड भयो भने कहीँनिर त ओके व्हेन एनीथिङ एक्सपान्ड्स, राइट, जग्गा कम्ती हुन्छ, त्यसले गर्दा एउटा जग्गामा ज्यादा भार पर्छ दुईटा जग्गाबाट. सो कम्प्रेसिभ स्ट्रेन लाग्छ एक्सपान्ड हुँदा. टेन्साइल कहिले लाग्छ भन्दाखेरि व्हेन टेन्साइल कन्ट्र्याक्ट हुँदैछ, यो तन्केर जाँदैछ, सानो जग्गाबाट यो तन्केर जाँदैछ, यस्तो जग्गाबाट, त्यसले गर्दा टेन्साइल स्ट्रेस लाग्छ. ओके, सो whenever in a transverse direction compressive stress acts to relieve the compressive stress, alikiti bhatkaउँछ हामीले, that is called the expansion joint. On the contrary, contraction joint चाहिँ कहाँ हो? Tensile stress लाग्छ. Tensile stress लाग्दाखेरि भत्काउँछ due to the change in, okay, kindly use different colors so that we can easily follow. Okay, problem भयो केही छैन. Fine, I'll do that. Okay, let's not break the flow la. ठिकै छ. This is the expansion joint array. Okay, and this is the contraction joint array, and this is the contraction joint array. Expansion and contraction joint array. Fine. So यसमा त्यो डिटेल भन्दा जाँदाखेरि पनि you just need to remember IRC values. Length between expansion joints 45 meters, sorry, basically spacing भनेको spacing between contraction joints is expansion joints is 45 meters. For contraction joint different thickness को basis मा हुन्छ. 10 centimeters को लागि 7.5 meters, 15 centimeters को लागि 13 meters and तपाईको 20 centimeters को लागि 14 meters. Okay, thereafter contraction joint मा के हुन्छ, dowel bars. Even expansion joint मा dowel bar हुन्छ. So dowel bar के गर्छ, holds the two parts together, यो part र यो part, and transfers the load from one panel to the other. So that is the function of dowel bars. Now let's move to the longitudinal joint. So longitudinal joint तपाईको यो particular direction मा हो, okay, longitudinal direction मा, and the maximum spacing as per the IRC is 140 meters and the joint thickness is 2.5 meters centimeters. Okay, longitudinal joint. यो चाहिँ किन act गर्छ? Okay, one more piece of trivia, 4 meters भन्दा ज्यादा छ अरे. Okay, त्यो केसेसमा हामीले longitudinal joint हाल्छ ताकि temperature stresses, warping stresses ले गर्दा ज्यादा impact नपरोस् भनेर. And finally we have something called construction joint. Your joint when there is an abrupt ending due to lack of land availability or due to some breakdown of machinery, your joint hamle create गर्छ, that is called construction joint. And another piece of trivia to give you, okay, तपाईको pre-stress concrete. So what it states is spacing should be 120 meters with minimum 3.6 and the minimum thickness of pre-stress concrete is 15 centimeters. Okay guys, with this knowledge, let's try to solve some MCQs. Are you ready? I hope you guys are ready. Okay, awesome guys. Let's go to solving those MCQs. Welcome to this question. Yeah. So please participate in poll. Poll number 3, I think. If I'm not wrong. No. Poll number 4. Please participate in poll number 4. As per IRC specifications, for contraction joints, in the RCC slab of thickness 20 centimeters, the maximum spacing is how much? Okay, poll number 4. Please participate. Theory question, no? I think you can directly give answer to this particular thing. Awesome, we have 33 votes already in. Beautiful guys. We'll end at 40 votes and we have crossed 40. Let's see la. हाम्रो के भन्दैछ, contraction joint भन्दैछ and thickness छ हाम्रो 20 centimeters. यसको लागि spacing कति हो भन्दैछ. Let's see. हाम्रो notes मा छ कि छैन. Contraction joint. Okay. Yeah, it is there. Height चाहिँ 20 centimeter भन्दैछ, spacing कति छ 14 meters, which most of you guys have given me the correct answer. Awesome guys. Option number D. Okay, around 90% of people have given me the correct answer. Let's move to the next one. Yeah, poll number 5. Come on guys. Pre-stressed pavements for highways can be built without joints in continuous length. Basically spacing कति हुनुपर्छ भन्दैछ. Spacing for pre-stressed concrete pavements. मैले ट्रिभिया भनेर तपाईलाई दिएको थिएँ नि, त्यही हो. Spacing for pre-stressed concrete pavements. मैले L बनेको थियो, B बनेको थियो and thickness बनेको थियो. Thickness I think 15 centimeter, width 3.6 and L के थियो. Basically spacing कति हो भन्ने सोध्दैछ. यस्तो पाराले किन गराएको भनेको, because तपाईको short term memory लाई I want to really awaken कतिको चाहिँ हुन्छ भनेर, so that your long term memory को लागि पनि तपाईको activate होस् भनेर. Come on guys, we will end at 40 votes. We have 38 votes in. Come on guys. Okay man, we can close the poll. So pre-stressed concrete pavement ko lagi we have 120 meters, which is given by option number. Okay, let's move ahead. Okay, यो मैले तपाईलाई भनेको छु, यो यहाँबाट नै तपाईले learn गर्नुस्. Poll number 6. So expansion and contraction joints provided in India for a smooth interference lead in winter. त्यस्तो किन सोच्नुस्, expansion र contraction joints मा चाहिँ कति डिस्टेन्स मा चाहिँ हामीले लगाउनु पर्छ भनेर. That is the only question that is being asked. Okay, guess गर्नुस् कति होला. Expansion and contraction joints मा को डिस्टेन्स चाहिँ कति हुनु पर्छ. So I haven't told you this particular thing. You can give a guess. Come on guys. It's for 30 votes more. Close. 22, 28, 29 and 30. Okay, we can close the poll. So it is option number B la. It is 50 to 60 meters. There is nothing to explain for winter. There is nothing to explain because it is already given. So expansion and contraction joints. Okay. Summer ko lagi it is 90 to 120. Okay. Just remember this much. Let's move to the next one. Okay, fine. Please participate in this poll. Interesting question. please use your common sense. Pavement blocks are recommended during construction due to what? Size of the block, water absorption capacity, low maintenance, or efflorescence. Guys, यसले common sense लायो अलिकति रिजिड पेभमेन्टको के भन्छ कन्सेप्ट अलिकति तपाईले लगाउन खोज्यो भने you'll get the answer. Rigid pavement, look, hint, rigid pavement को कन्सेप्ट भनौँ न. यो जो डिफरेन्सेस हेर्नु मैले अलिक गरेँ नि, राइट? त्यहाँबाट तपाईले एप्लाई गर्न सक्नुहुन्छ. पेभमेन्ट ब्लक भने मोर or less it is a rigid pavement हुन सक्छ. Because block भने पनि it's cement concrete. It might be reinforced, it might not be reinforced. It all depends, you know. Okay, I think we can close the poll. We have exceeded 45 votes. So, as I stated, rigid pavements are high maintenance or low maintenance? H or L? It is low maintenance. So, it is option number C. Size of the block? That doesn't matter. I know. Panel one यति ठुलो पनि हुन्छ, सानो block पनि हुन्छ. So, okay, there is no consistency for this particular option. Oh, water absorption capacity. त्यति साह्रो त अब्जर्भ गर्दैन because तपाईको flexible pavement ले ज्यादा अब्जर्भ गर्छ हाम्रो. Maintenance, yes, of course it is low maintenance as compared to the flexible pavement. And efflorescence, त्यस्तो केही अब against way छैन. अब salt ज्यादा छ भने त obviously यसले पनि reaction देखाउँछ. So, as such, low maintenance is the apt description for pavement blocks. Let's move ahead. Okay. So in expansion joints, the loads are transferred to what? Please participate in poll. Expansion joints, I think poll number 8. Okay. In the expansion joints, the loads are transferred through which of the bars? To aggregate the bars. Transfer. I hope there is no mistake in this particular thing. Please guys, participate in the poll. I hope to have more participation in this. Okay, we have 48 votes in and we can safely end the poll. Okay, fine. We have 51 votes, 52 votes. Awesome guys. So, कुनचेले चाहिँ load transfer गर्छ त्यही मात्रै हो किनकि तपाईको expansion joint and contraction joint. Expansion joint and contraction joint. Both ma you have double bars. यसमा मुन्छ बनेको छ, यसमा मुन्छ बनेको छ. So double bars के हो? Transfers load from one panel to another, while tie bars only holds the two parts of the pavement together. Okay, so B, double bars, is the correct option where loads are transferred in case of expansion joints. Okay, there's another question. Please participate in poll number 9. Which of the following joint types primarily relieves tensile stress in concrete pavement? So tensile stress relieve गर्ने कुन चाहिँ type of joint हो? Okay, tensile strength. एउटा compressive strength release गर्ने joint थियो, एउटा tensile stress relieve गर्ने joint थियो. So both joints act in the same direction. त्यहाँबाट tensile stress कुन चाहिँ थियो, compressive stress कुन चाहिँ थियो. Important to consider. Okay, then I think we can safely close the poll. Okay, देखाइदिइहाल्छु तपाईलाई notes बाट. So compressive strength release गर्ने expansion joint हो and tensile stress relieve गर्ने contraction joint हो. Okay, so हामीलाई tensile stress भन्दा side is the contraction joint, which is given by option number C, which most of you guys, around 90% of you guys have given you the correct answer. Let's move ahead. Okay, okay. Please participate in poll number 10. Expansion joints are provided if the length of concrete structures exceeds. So maximum spacing of expansion joint one is maximum spacing of expansion joint. You can participate in poll number 10. So someone has raised the hand. Ki issue थियो? Namyong mi. Any issue? Yeah, Jukul Matichi पठाउनु भएको. If any issue, you can speak up or you can comment in the chat. So मलाई एउटा अघि ममताले सोध्नु भएको building joint and pavement joint are the same. So it depends, you know. Spacing हेरु त अब के भन्छ तपाईको different obviously हुन्छ. So joint भन्ने same हो. Joint भन्ने basically spacing हो. Building मा पनि अलिकति gap हामीले राख्छ so that expansion contraction हुन्छ. Not just building, bridge joints हरु पनि हुन्छ हाम्रो, right? Expansion contraction मा हाम्रो काम हुन्छ. Pavement joints पनि joint are the same, but जुन specification छ that will differ. Okay, अनि प्रशान्तले सोध्नु भएको छ, so thickness is width of joint or depth? Thickness is the width, depth अर्कै छ तपाईको. Okay, let us see the participation in the polls. Okay, just let me see activities. Poll number 10 भनेको छ लाग्यो मैले. Yes, so we have 45 votes. Awesome. So I think we can close the poll here. So expansion joint spacing of expansion joint, maximum spacing of expansion joint चाहिँ कति थियो? It is 45 meters. So most of you guys have given me the correct answer, which is option number D. Okay, there's another one. Pole number 11. Come on, guys. The surface where two successive placement of concrete meet are known as two successive placement of concrete meet are known as. This is a new thing. So कतिवटा चाहिँ MCQ गरेर याद राख्नुपर्छ तपाईले. Okay, we can close the poll here. Just remember it is construction joint. यो construct गरिसक्यो, त्यहाँदेखि यो construct गर्न थाल्यो. Successively meet गर्ने joint लाई चाहिँ हामीले construction joint भन्छ. Okay. You're not necessary for the time being. Okay, you can attempt this SSC 2011 research. Poll number 12. In which of the following items is not considered while designing rigid pavements? Which of the following items is not considered while designing rigid pavements? Okay, हामीले एउटा गरेको थियो. Westergaard stress हामीले consider गरेको थियो. If we consider those, त्यहाँबाट somewhat हामीले निकाल्न सक्छ. Which of them is not considered for designing rigid pavement? Westergaardले पनि totally त दिँदैन. Okay, design गर्दाखेरि I'll tell you, जहिले भए weakest plane मा हामीले design गर्छ, right? Weakest plane मा हामीले design गर्छ. हामीले suppose तपाईले RCC को लागि पनि पढ्नु खोज्दाखेरि हामीले जानेर strongest जग्गा छ, त्यो strongest जग्गामा त we never design because weakest जग्गा strongest जग्गामा suppose 100 किलो न्यूटन पर स्क्वायर मिटर compressive stress हामीले बेयर गर्न सक्यो, तर weakest मा 50 थियो अरे हो. सो हामीले 100 हुन्छ भनेर डिजाइन गरिनु पाएन नि, because 50 मा ब्रेक पनि त हुन सक्छ. So we choose the weakest plane. Okay, so त्यो लजिक कन्सिडर गर्दा रिजिड पेभमेन्टमा कहाँनिर चाहिँ स्ट्रङ्गेस्ट हुन्छ त्यहाँनिर we don't consider, कहाँनिर चाहिँ weakest हुन्छ we consider. So यसमा भन्दैछ which of the following items is not considered while designing rigid pavement? So strongest जग्गामा चाहिँ we generally do not tend to design. We tend to design at weaker planes. So I think we can safely end the poll here. Let me ask you a small question. 50-50 छ तपाईहरुको यहाँ त्यस्तो रहेछ. So let me ask you a question. यो चारटाबाट strongest plane चाहिँ कुन चाहिँ होला? A, B, C, D. Can you please comment? Come on guys. Come on guys. Yes. Awesome. Awesome. जे मलाई चाहिएको थियो, you guys have given me the correct answer. So कुनै डिजाइन गर्दाखेरि सेन्टर त maximum bending moment हामीले बेयर गर्छ नि जनरली. अब या simply supported मा पनि for let's consider. Okay, simply supported मा it was something like this, हैन, bending moment. So maximum bending moment यहाँ हुन्छ. त्यसले गर्दा center of the panel जहिले भए पनि बलियो बनाउँछ. So we do not consider designing rigid pavement at the center. कहाँ साइडमा अचानक के भत्केर जान सक्छ, राइट? त्यस्तो डरलाग्दो केसेस या एजेसमा भत्केर जान सक्छ, या यसको बीचमा सरी त्यो त कन्ट्राक्सन जोइन्ट मात्रै हुन्छ, यसको बीचमा डाबल बार छ अरे त्यो भत्केर जान सक्छ हो. सो दिज आर वीकर प्लेन्स. यो भत्केर गयो भने यति हाम्रो एडभर्स कन्डिसनको लागि हामीले कन्सिडर गरेको छ भने डिजाइन हुन्छ नि. बेसिकली भेरी एडभर्स कन्डिसनको लागि पनि हामीले थाम्न सक्छ रोड. द्याट्स वाइ we do not consider design at the option number A, that is center of the panel. We do it at the edge because bhatkera jana sakcha. Edge त यो पो भयो. We do it at the corner and we do it at the dowel bar between the edges. I hope you have understood this. So use of common sense ल जहिले भए पनि engineering मा, especially civil engineering, electrical मा गर्न सक्ला, mechanical मा गर्न सक्ला, but civil engineering मा we can use common sense, right? Okay, let me see अरु क्वेशन्स हरु सकिन्छ. Okay, fine. You the गरे हो जस्तो लाग्यो. Okay, please, I think this was a SPSC question. Please participate in the next poll. I think this was an SPSC question. Please participate in poll number 14. Poll number 13. Okay, the purpose of expansion joint. किन चाहिँ हामीले expansion joint राख्यौं? Now this is अलिकति tricky है. अलिकति tricky है. Think about it. अलिकति words हरुमा तपाईहरुको उयो छ. Be careful with that. Okay, I think we can safely conclude the poll here. So Isma, I think it requires a little bit of explanation. So I'll just draw in it away. Expansion joint. So expansion joint is similar to that of a construction joint. Okay. Yeah, expansion joint के ले गर्दा हुन्छ? Warping ले गर्दा हुन्छ. It is due to warping. Warping भनेको के हुन्छ? For example, यस्तो simple slab थियो रे. त्यो slab चाहिँ यस्तो हुन्छ. किनकि माथि surface मा heat हुन्छ, expand हुन्छ, अनि त्यो expand control गर्नको लागि एउटा compressive stress लाग्छ. Similarly, bottom मा contract हुन्छ, त्यसलाई contractलाई बचाउनको लागि एउटा tensile stress लाग्छ. Okay, so that is happening. Now expansion joint मा हामीले किन भत्काएर राख्छ? मेन पर्पस चाहिँ के हो? भत्काएर राख्नको लागि, ताकि चाहिँ यो बढेर आउँदाखेरि हो कम्प्रेस हुनु खोज्दाखेरि यहाँ अलिकति जग्गा होस् यो बढेर जाओस् भनेर द्याट इज द थिङ सो नम्बर ए लेट अस कन्सिडर रिड्युसिङ वार्पिङ स्ट्रेस अब वार्पिङ स्ट्रेस त टेम्परेचरले गर्दा त हुन्छै हुन्छ नि वार्पिङले गर्दा चाहिँ हाम्रो एक्सपेन्सन या compressive stress or tensile stress in case of construction joint, a contraction joint, and compressive stress in case of expansion joint. Okay, this is the result of this causes compressive stress and tensile stress. But exactly expansion joint मा चाहिँ को actual purpose त warping stress reduce गर्नु त होइन नि यसले त impact भएको actual हाम्रो logic चाहिँ के हो भन्दाखेरि यो खुल्ला हामीले राख्नु पर्यो ताकि यो हाम्रो इन्क्रिज भएर आउँदाखेरि अलिकति फ्रीली मुभ गर्न सकोस् ताकि भत्केर joints don't break, right? Joints are created so that the pavement does not break. Okay, so it is not reducing warping stress, but it is permitting free expansion. Okay, what causes this भनेम त यो हो तर purpose of expansion joint is to permit free expansion of rigid pavement. Okay guys, बुझ्नु भयो भएन you can give me a thumbs down. Okay, awesome guys, awesome. Okay, so यो तपाईले देख्नु आँखाले देख्दैछ कि त्यसले गर्दा I think it's quite clearer to you guys. Okay, let's see if you have another question. Okay, can you guys guess? यो मैले पढाएको छैन यो तपाईको combined recruitment exam मा आएको रहेछ. Expansion joint in cement concrete pavements are provided at which interval? Expansion joints in cement concrete pavements. मैले maximum expansion joint मैले तपाईलाई provide गरेको थिएँ, right? That is 45 meters maximum spacing. Can you please guess? यसमा कति होला भनेर. Poll number 14. यसमा wrong भयो के छैन, it's just a factual thing. अहिले wrong भयो केही छैन यो याद भयो भने त बादमा राइट हुने नै हो तपाईहरु. Okay, there is no issue. We close at 30 votes. I think we are at 30 के छैन. So please don't get disheartened. It is 18 to 21 meters. This is a factual thing ल केही कन्सेप्ट मा तपाईको गडबडी छैन खाली याद हुने चीज मात्रै यो अब तपाईलाई याद पनि भइसक्यो रिभिजनले गर्दा फेरि बेटर याद पनि हुन्छ तपाईहरुलाई. Okay, 18 to 21 meters के हो बेसिकली एक्सपेन्सन अफ expansion joint in cement concrete pavements are provided at what interval? It's a maximum हो यो चाहिँ generally हाम्रो इन्डियामा प्रोवाइड गर्दैछ. Okay, fine. Okay, China. Okay, now think let's go to one or two numericals now. So मैले basically तपाईलाई I've introduced you guys to expansion joints. I've introduced you guys to contraction joints. तर expansion joint, contraction joint को formula पनि छ यसमा. Okay, I'll just introduce this formula to you guys. So let us begin with contraction joint. Okay, contraction joint, just remember this formula. L is the spacing of contraction joint, which is equal to 2 of sigma st. Sigma st माने pressure हो basically. Steel मा stress कति लाग्दैछ भनेको into ast. This is the area of steel. So again I'm saying, sorry, let me draw this pavement. Let me draw the rigid pavement again. This was the contraction joint and these were dowel bars. So इसको area इसमा pressure कति लाग्छ, that is the stress कति लाग्छ, that is sigma st. and the इसको area of cross section of steel is ast. Okay, sigma st ast divided by bh gamma concrete into f, where b is the width of the rigid pavement, h is the thickness of the rigid pavement, gamma concrete generally it is the density of concrete, unit weight of concrete. इसको generally 2400 kg per square centimeter, cubic centimeter generally. Okay, and f is the friction coefficient. Okay, so this is the formula for contraction joint, and the formula for expansion joint is L alpha delta t is equal to by 2, where L is the spacing, this is the temperature coefficient, this is the change in temperature, and this expansion joint को gap. So basically your width gap is delta. Okay, so this is one formula and this is the other formula. Okay guys, can you remember these two formula? Okay, I hope you guys can remember. Now please I'll give you 15 seconds to just see these formulae so that तपाईलाई सजिलो हुन्छ हाम्रो numerical solve गर्नु. Okay guys, are you guys ready for some more numericals? Okay, awesome guys, let's begin. के छैन formula लेखिदिन्छु नि, don't worry. Okay, so this is okay. What total cross-sectional area of longitudinal reinforcing steel is required for cement concrete pavement slab? The concrete working stress so and so. So according to the diagram, slab contraction भन्दैछ. So we need to use contraction joint को formula. So that was given by L is equal to 2 sigma st by AST divided by BH gamma concrete into F. Now हामीले total cross-sectional area of longitudinal reinforcing steel भन्छ. So let me rearrange this particular AST is equal to LBH gamma concrete into F by 2 sigma ST. So guys, solve गर्न सक्छ भने you can solve and comment in the chat. Okay. So let me write के रहेछ. Pavement slab 3.75 meter wide. So B is equal to 3.75 meters. Length is 15 meters long and thickness is 0.2 meter. That is 200 mm. Concrete weighs 2400 kg भनेपछि gamma concrete 2400 kilogram per cubic meter and working stress sigma ST is 1400 kilogram per cubic centimeter and small f is equal to 1.5. Okay guys, so if you can substitute this over here, please tell me the answer. You can comment directly in the chat. I'll be waiting for your response. Come on guys. Mirak Yonghang Le answer dinu bhako रहेछ. I'll have to check. Come on guys, तपाईहरु पनि solve गर्नुस्. I'll just write it down la. Please wait, I'll give you the answer. So just let me see. Check the answer. Yes, most of you guys are right. It is 14.46 square centimeters. Okay, so the cross-sectional area of the dowel bars basically is 14.46 square centimeters. Okay guys, Budhu Bhainam, you can give me a thumbs down. Else, please give me a thumbs up. Okay, awesome guys. Awesome. Let's move ahead. Now, not square meter. Let me see la. I might be wrong also. Yes, you're right. Yes, just let me see. F into AST into AST F into AST. Okay, if you think about it, BLH त्यसलाई मैले cancel out गर्यो. Just गर्यो. Square meters. No, it will be square centimeters only. Okay, formula is designed as such. It will be square centimeters only. Square meters भन्दैन. Think about it. Square meter is too big नै हैन. सोचिहेर्नुस् त. 1 meter भनेको कति 3 फिट हो, राइट? 14.46 भने त आमामा 3 फिट 3 बाइ झन्डै एउटा घर जस्तै भयो त त्यो त, राइट? कति डरलाग्दो ठुलो हुन्छ. सो यु नो त्यो कन्सिडर गर्दाखेरि प्लिज कन्सिडर मतलब फर्मुलाबाट उयो कन्सिडर गर्दाखेरि इट इज लेसर. अलिक रियलिस्टिकली सोच्नुस् कि द्याट विल गिभ यु द राइट डाइरेक्सन. यो फर्मुला नि यस्तो डिजाइन छ which will give you square centimeter. I can understand it त्यसलाई. तपाईले यो मिटरमा लियो, यो मिटरमा लियो, यो पनि मिटरमा लियो, त्यो अर्को चाहिँ किन भएन टाइप्स पनि, राइट? त्यो बेसिकली के भयो म तपाईलाई देखाउँछु. ओके, जस्ट लेट मी एलाबोरेट दिस पर्टिकुलर थिङ ल. L यसमा मिटर थियो, राइट? B मा पनि मिटर थियो, H मा पनि मिटर थियो, राइट? एन्ड गामा कन्क्रिट जुन चाहिँ छ किलोग्राम पर क्युबिक मिटर भयो. ओके, इन्टु F को त नो युनिट, यसको त के युनिट हुँदैन. डिवाइडेड बाइ 2 into sigma ST भन्दैछ. sigma ST भन्ने पनि किलोग्राम पर क्युबिक सेन्टिमिटर. क्युबिक हैन, स्क्वायर सेन्टिमिटर हुन्छ. सरी, स्क्वायर सेन्टिमिटर किनकि स्ट्रेस हो. सो m क्युब क्यान्सल्स आउट, केजी क्यान्सल्स आउट. यो माथि गयो भने स्क्वायर सेन्टिमिटर. ओके, सो त्यसले गर्दाखेरि स्क्वायर सेन्टिमिटर आको एन्ड स्क्वायर मिटर नभएको. ओके, जस्ट रिमेम्बर नि यो यस्तो टकुदुक्दो गर्नु पर्दैन नि. जस्ट रिमेम्बर दिस मच. ओके, so let's move to expansion joint here. Mazako question there. I wanted to do this. Okay, now the width of, okay, just let me write the formula for this. L alpha delta T alpha by 2. Okay, question now, width of the expansion gap, that is del, is equal to 2.5 centimeters. In a cement concrete pavement, if the lagging temperature is 10 degrees, T1 is 10 degrees, and maximum slab temperature is 54 degrees, delta T is equal to T2 minus T1. That is 44 degrees, and calculate the spacing in the expansion joint. L khod baneko, assuming, see, coefficient of thermal expansion is 10 to the power minus 5 per degree centigrade. Okay, so this is the formula. Yela sajilo parale gare bhani ta by 2 alpha 30. Please calculate. I won't solve this. Come on guys, please calculate and give me the answer in the chat. I'll be waiting for your answers in the chat. So Pranay le hamलाई सोधेको रहेछ, it's total AST required in total cross section हैन. सपोज मैले यस्तो क्रस सेक्सन गरे भने यो तीनटा एरियामा त्यो AST. entire त suppose h by b भयो नि bh हुन्छ नि total area right त्यसमा area of concrete is bh minus ast basically तपाईले यो concrete मा गर्नुहुन्छ okay yes total area of steel correct please Pranay यसमा solve गर्नुस् let's see if you guys are right or wrong let me check the answer 2840.9 millimeters or 28.41 meters. Awesome guys, you guys are correct. Awesome guys. So more or less we have come to the end of this chapter. एउटा सानो point छ ल म तपाईलाई डिस्कस गरिहाल्छु and then this is also over. Okay. So just remember critical combination of stresses. समर को लागि हुन्छ एउटा विन्टर को लागि हुन्छ एउटा नाइट को लागि हुन्छ ओके सिग्मा लंगिट्युडनल एज मा सो हामीले अघि वेस्टरगार्ड इक्वेसन पढेको थियौं राइट एउटा इन्टिरियर थियो एउटा एज थियो एउटा कर्नर थियो सो समर मा एज प्लस वार्पिङ एज माइनस फ्रिक्सन सो क्रिटिकल कम्बिनेसन अफ स्ट्रेसेस भन्ने त्यो स्ट्रेस हो हामीले त्यो स्ट्रेस डिजाइन गर्नुपर्छ एउटा पर्टिकुलर पेभमेन्टको लागि रिजिड पेभमेन्टको लागि ताकि फेल नहोस् भनेर सो जस्ट रिमेम्बर एजमा लंगिट्युडनल एज फर एक्जाम्पल लंगिट्युडनल एजमा हाम्रो कति चाहिँ स्ट्रेस लाग्छ यो फेरि तपाईको ट्रान्सभर्स एज ओके लंगिट्युडनल एज इज दिस वान त्यहाँदेखि वार्पिङ एज टेम्परेचर चेन्जेसको लागि कति एजमा तपाईको स्ट्रेसेस लाग्छ माइनस फ्रिक्सनल फोर्सले कति लाग्छ जस्ट रिमेम्बर दिस डाइरेक्टली सोध्न सक्छु तपाईहरुलाई विन्टरमा longitudinal edge, warping edge plus frictional strength. Just remember this formula. It's the directly MCQ में सोध्न सक्छ. And finally, longitudinal corner plus warping corner. Okay, guys, just remember this much. And the final thing, तपाईको थियो भन्दा basically it was design of rigid pavement. So it comes under difficult questions, which is very low probability of coming. Okay, entire design छ तपाईको which is very low probability of coming. So what I'm thinking is एक खेप तपाईले syllabus complete गर्नुस् entire and हाम्रो later on when we have doubt clearing session I'll be taking up this if you guys want me to do this. Is this okay? म तपाईलाई बेकारको लोड दिनु मन छैन because this might not come. There's a great possibility this will not come. Okay, that's why I do not want to burden you with this particular thing. गर्नु त केही छैन हिजो जस्तै हुन्छ फेरि I really thought about yesterday's class कि एउटा मैले डिफिकल्ट क्वेशन गरेछु तपाईहरुसँग so I really thought about it and I don't think this is very much required. Okay, now guys please don't go, we have 20 minutes. So by the way, one small announcement. I've talked to the team. Tomorrow we'll do a holiday la. We'll keep tomorrow as off. Okay guys, I hope you guys are coming engagements are sala. I think you guys will be busy. Oh, I won't talk much in that matter. So tomorrow we'll be conducting a holiday. Okay, I've talked to the team also and they have agreed. And I'll be continuing with transport on Saturday. Please don't leave a portion charge. Okay, fine. Saturday we'll be continuing. So let me tell you, ke bhag cha hamroma. So तपाईहरुलाई लाग्यो होला soil mechanics भन्दा transportation was very vast. Did you think, guys? निकै लामो भएको जस्तो लाग्यो? It's quite long, right? See, तपाईको even हाम्रो 28 एउटा तपाईको टपिक्स छ -1 गरौँ किनकि युनिट्स भन्दा 27 टपिक्स इज द एन्टायर सिलेबस त्यहाँबाट सोइल जियोटेक्निकल इन्जिनियरिङ वाज जस्ट 1 तपाईको सर्वे पनि जस्ट 2 थियो त्यो त तपाईको सानो नै थियो एन्ड ट्रान्सपोर्टेसन दिस 3 टपिक्स एन्ड 3 टपिक्स पनि यति साह्रो एलाबोरेट थियो that's why it took us so much of time. Okay, now isma pani today we have finished the design of pavement. I want you guys to look at pavement evaluation and maintenance. Okay, notes are there. So I'll give you a sneak peek 5 minutes so pavement evaluation regarding it is well safely understood. Ek reading launus, 2 reading launus, MCQ solve garnus, that will be it. The depth ma janu parदैन because this is a very small and a very easy topic. त्यसको बादमा just one topic remains, तपाईको railway, which I intend to finish on Saturday. Okay, railway ma super elevation के छ अलिकति repetition छ माथिको हो and तपाईको railway मा number of sleepers भन्ने जुन चाहिँ पुरा रिपिट भइबस्छ हाम्रो एसपीएससी मा त्यो छ नै छैन सिलेबसमा सो त्यसले गर्दा मोस्ट पार्ट अफ द सिलेबस हाम्रो घटिहाल्छ त्यसले गर्दा I intend to finish this in one class. Okay guys, with that let me give you a brief about pavement evaluation and maintenance. And plus, those guys who want to study for tomorrow also, त्यसले गर्दा you can study pavement maintenance and evaluation. त्यसले गर्दाखेरि चाहिँ I will just introduce this small topic to you guys, and then we can be off. So, just look at this diagram. You तपाईँले जुन चाहिँ प्याटर्न देख्नुहुँदैछ रोडमा यस्तो देख्नु भएको होला आई थिङ्क यु मस्ट हेभ सिन राइट हेभ यु सिन सच प्याटर्न्स यो पिक्चरमा त देखिरहेको छ तर इफ यु हेभन्ट अल्सो कहाँनिर तपाईँले अब्जर्भ गर्नुहोस् ओके जस्ट अब्जर्भ ओके सो यो जुन चाहिँ प्याटर्न फर्म भएको छ तपाईँको स्क्वायर टाइपको प्याटर्न राइट अलिकति इरेगुलर टाइप अफ प्याटर्न डजन्ट इट लुक लाइक द स्केल्स अफ एन एलिगेटर अर क्रोकोडाइल होइन डजन्ट इट लुक लाइक द्याट उनीहरूको छाला यस्तो टाइपको हुन्छ राइट सो इन द्याट केस सच टाइप अफ क्र्याक्स आर नोन एज एलिगेटर क्र्याक्स ओके सो तपाईँले बादमा केही तपाईँले वेन यु गेट इन द सर्भिस के रिपोर्टहरू लेख्नु पऱ्यो भने के इस्यु भएको छ भने यु क्यान टाइप राइट एलिगेटर क्र्याक्स बिकज इट लुक्स लाइक एन एलिगेटर एलिगेटर्सको स्केल्स बेसिकली अनदर टाइप अफ पेभमेन्ट डिफेक्ट बेसिकली तपाईँको इज दिस पर्टिकुलर थिङ लङ्गिट्युडनल डाइरेक्सनमा क्र्याक यो फर्म हुँदैछ राइट दिस पर्टिकुलर थिङ ए सरी cannot draw here or what? No, I cannot draw this case. I cannot draw. So, यो particular crack like a longitudinal cracking. So, तपाईले एउटा चीज नोटिस गर्नुहुँदैछ just look at the thing, just look at the yellow line. त्यहाँनिर what type of joint form भएको रहेछ if you can see. That is called a what type of joint? अहिले हामीले भर्खर पढेको थियौ. It is a what joint? Yes, it is a longitudinal joint. Okay. So, हाम्रो practical example यहाँ देखिहाल्यो. Okay. Okay, let's move to the next one. So, यो चाहिँ कसरी फर्म भएको होला? Can you guys guess? यो कसरी भएको होला? Can you guys guess? यो type of defect चाहिँ कसरी भएको होला? Water ठिकै छ तर warping it's okay तर yes breaking परिष्कृत you are right. Breaking गर्दा या चक्क अल्झेर स्किडिङ गर्दाखेरि हैन यस्तो हेर्दाखेरि doesn't it look like that? So, that's why it is called slippage cracking. टायर स्लिप भएको त्यहाँनिर ओके स्किड होइन स्लिप भएको त्यहाँनिर आई होप रिमेम्बर त्यो हामी ज्योमेट्रिक डिजाइनमा स्लिप र स्किड गरेको थियौँ नि स्लिप भनेको चाहिँ त्यो मुभै गर्दैन तपाईँको द मुभमेन्ट अफ द भेहिकल द मुभमेन्ट अफ द सर्कम्फरेन्शियल मुभमेन्ट इज ग्रेटर देन द्याट अफ द मुभमेन्ट अफ द भेहिकल ओके दोज आर कल्ड स्लिप्स द्याट इज कल्ड स्लिपेज क्र्याकिङ एन्ड दिस वान इज कल्ड रटिङ मैले अस्तिदेखि रटिङ भन्दै थिएँ नि सो ट्रान्सभर्स डाइरेक्सनमा यस्तो ग्रुप्सहरू फर्म भयो अरे uneven undulations theory, right? This is called rutting. Is this clear? Okay, guys. I hope you are able to visualize this well, right? This is a very interesting thing if you think about it, right? Okay. Now, okay. Please look at this one. This is also the same thing. So, what is the difference between corrugation and rutting? Can you tell me? यहाँ पनि त undulations चाहिँ form भएको छ, right? माथि मुनि. यहाँ पनि undulations छ. Yes, awesome. So then. That is what exactly I was looking for. Rutting takes place in the transverse direction and corrugation takes place in the longitudinal direction. Okay, I hope you guys are getting this. These, by the way, these are defects in flexible pavement. इसको solution हम देखें कि seal joint के रहता है fork seal joint के रहता है. Please go and see. And what is this called? This is called a what? Yes, awesome pothole. Most famous type of defect in Sikkim. Okay, now after that. Let's come to rigid pavements. Now, if you look at this, rigid pavement ma shrinkage cracking bhन्छ तपाईको. Let's look at this. Shrinkage cracking. Shrink भएर यस्तो पाराले cracks हुन्छ. Rigid pavement. Okay. And this one is called joint spalling. So, whatever I said, right? It might be a construction joint. It might be a तपाईको expansion joint, construction joint. त्यो joint को end मा यस्तो पाराले भत्केर जान्छ नि हाम्रो pavement. So, that breaking down of the slab near the edge is basically called joint spalling. Okay, guys? Clear say यति नै छ मेरो defects हरु. Okay? So tomorrow को लागि I have given you some fodder material. हो त्यो लिएर जो जोसिलो मान्छेहरु छ जो busy छैन उनीहरु they can study. जो busy हुनुहुन्छ I hope you can catch my drift what I'm trying to say. Okay? So I think we can end the class today. What's it, madam?
Thank you so much, Sonam sir. Happy holiday, everyone. Enjoy Warner.
Okay,
stay safe. Good night.
Okay. Yes. Merak, you're absolutely right. Okay, then good night, everyone. I hope you have a good holiday.